Hello, guys. Today you have a nice session with the digitalization and AI approaches with company MLTune. I'm Vlad Lauchin. I'm the owner of company MLTune, the strategic partner for your AI integrations for digital twins and new technology inside of your business. We work not only with oil and gas, we also work with engineering companies. So today, I would like to explore a fascinating topic that is a buzzword right now. Last time we've been discussing the digital twins and what are they and how they operate, but I've been getting some questions from people around, like from my customers and from other experts in the market. Like, what is the difference, basically? What is the difference between the digital twin and actual machine learning and data science, which are like notably changing directions right now? Like recently, the data scientist was the researcher that like needed to do long time of the chains of the research, and then the machine learning experts evolved over time so they can tackle these problems right now. But it's not only about this. Like the digital twin technology requires lots and lots of years of experience in engineering, in understanding the background and domain. So this is the main issue that we are facing right now. Like everyone is talking AI, AI, AI. Everyone is like doing these researches in ChatGPT and Perplexity and DeepSeek and other things and thinking that everything can be solved with this, but it's only words. The problem sits on very much lower levels. We need to understand that doing the AI inside of and integrating the AI and machine learning inside of the engineering operations or any production operations is very, very tremendous task. And you need to understand the major differences. So today we're going to talk about the difference between the digital twins itself, as the idea, as the notion, versus traditional machine learning methods. And what are the advantages one over the other one. So let's break down the key differences and, for example, how deep learning and optimization strategies are integrated. And then we're going to briefly touch on essential tools that you need to create when dealing with the digital twin. So I propose to get started. What is the key difference between a digital twin and standard machine learning models in engineering? First, let's define our approaches. Traditional machine learning, ML, models rely on statistical and computational methods to identify patterns and historical data and make predictions. They work very well for tasks like predictive maintenance, but often lack real-time adaptability. There is certain things done already on the market to retrain the models, to facilitate the data degradation, to facilitate model degradation. So everything is already been integrated, but some of the processes that require tweaking by the engineers is overseen. So on the other hand, digital twin technology is a real-time, continuously updated virtual replica of a physical system that integrates live sensor data, physics-based models, and engineering knowledge with the artificial intelligence. Unlike standard ML models, it doesn't just predict outcomes, but simulates and optimizes complex engineering systems in real time. So by this, I mean, like, for example, let's take any engineering example. Say we want to optimize the fracking operation inside of the well. So it consists of several components. The worker force that is going in and does the pump down job inside, and the pumping itself, and the pump and microseismic team that is doing the pumping and monitoring the pumping. So, for example, we need to have some kind of benchmark model that has to generate the best outcome. But in order to have it, you need to have lots and lots of data previously collected to simulate the outcomes and then select the best outcome of the fracking operation. For example, there is a big demand for closure stress log at the moment and predictions of the fractures closing. There is certain technologies developed years and years ago, but they are lacking this AI impact. They're lacking AI solutions because everything is done in Excel. Everything is done by hand. This is the major difference. AI and machine learning techniques are starting getting in them, but they are solving only small problems. With the digital twin technology I'm introducing, and we machine learning, ML-Tune producing the actual outcomes of the operational efficiency in real time. So what is the key difference? Machine learning models are predictive, while digital twins are prescriptive and adaptive, providing a real-time decision-making framework rather than just static predictions. So how do you, how we combine deep learning and optimization strategies in the models? I think one of the most powerful aspects of digital twins is the ability to combine deep learning with optimization strategies, with linear programming. It's a combination of optimization engines versus some models that are figuring out the puzzles of predictions inside of the model. But overall, there has to be orchestration system that controls this set of solutions in one spot. So this is how the digital twins are different from machine learning. Machine learning is just the small solutions for specific problems. Digital twin is the organized, orchestrated way of utilizing the machine learning versus the optimization versus the linear programming. So for example, those models like deep learning for pattern recognition, we use the neural networks that analyze vast amounts of sensor data and operational data to detect anomalies, predict failures, and refine models. There is physics-based optimization. Instead of relying purely on machine learning predictions based on the data, digital twins integrate domain knowledge, engineering simulations, and optimization algorithms to fine-tune processes. Also, we can utilize some reinforcement learning. In the digital twins, we can leverage reinforcement learning to simulate multiple operational scenarios and choose the best strategy in real time. I believe this fusion allows digital twins to go beyond static machine learning models, continuously learning and improving based on real-world conditions. What are the essential tools and platforms for building a digital twin? It would be nice to touch base on that. So let's talk about the tools and platforms. So you would need to have simulation software written in Python or MATLAB. There are certain things like Simulink, ANSYS Twin Builder. Google is given some optimization capabilities. IBM Watson's, but they are all closed off. There is some systems like Dassault Systems, 3D Experience that are widely used for physical simulations. We need to talk about the IoT and cloud platforms utilizing Azure digital twins that is available at the moment. We can think about AWS IoT Twin Maker, Siemens MindSphere. Those provide cloud-based infrastructure to scale your digital twins technology. It depends on your appetite of your company and the budget that you would like to allocate on that. This requires specific architectural design and broad, thoughtful process for architecture and planning of deployment of these tools. So AI and ML tools that are integrated in this are Python and TensorFlow, PyTorch, and other things like scikit-learn, and there are lots and lots of technical things that we can talk about, but mostly this is done by the experts in the market. So basically, what I'm trying to say is that by domain knowledge, we need to have experienced people that have some data science work done, but they've been coming from the engineering background and they understand the whole process of the operation that we are building the digital twin for. Then we need to consider hiring a less heavy educated, less heavy experienced personnel that can do the machine learning integrations into the business, basically. So in the last point, we need to figure out the edge computing part. So there is a notion right now in the market that in order to have a better and higher latency solutions for your plants and for your operations, you need to be able to compute your data based on your premises. So there is a longer communication and discussion going on whether you can run your models on the cloud versus you need to run them on site. Some of the new technologies coming up from NVIDIA Jetson with the new GPU units start to allow you to do a better compute, pre-compute, so you send less data to the cloud that will allow you to have your calculations done in a faster manner, in a better way, and so your team and your managers have a better view over the processes right away. So yeah, as I said, NVIDIA Jetson, Intel Edge Insights, and Google Coral enable real-time processing of data at the source. So like we need to think about that and how to integrate this. So these tools create an ecosystem where the data flows seamlessly between sensors, AI models, and real-world application. So yeah, like when dealing with the data analytics, we also need to take care of pre-processing. So there is a notion, the garbage in, garbage out. So you need to be careful with the training of your models. You need to be really precisely interviewing your stakeholders and figure out how we can make the biggest impact on the problem that we are trying to solve, and how to bring the most return on investment for integration. So main thing here is that we want to increase the operational efficiency and decrease the cost. And by this, we need to integrate the fully autonomous system that is capable of solving problems for the client. This is the major thing that needs to be discussed, and that's how I operate and I talk to my clients, for example. We need to think proactively, we need to think into the future, we need to look into competition, and the world has never been fast as it is right now. With the new technologies coming up, with the new solutions, everything that has been done weeks and weeks, now it's done in one day by leveraging the power of new solutions like DeepSeek, for example, is a beautiful example for R&D. Like a couple years ago, my team had to do R&D, skimming through the articles themselves and reading and understanding. Right now, this is no need anymore. There is a system that is like you can write the script, you can connect the APIs, you can build your own agent that will be hovering over this information specifically and building the output for you. You just need to have enough expertise to integrate that. You cannot utilize these solutions based on the ChatGPT solution. There is no way. You're gonna fail. You have to have a domain expertise, and that's why MLTune is best partner for you guys, because we have a team of very experienced people working for BP, for Shell. Myself, I've come in from North America, from Canada. I've been doing a bunch of operational integrations for optimization in the Alberta region, doing the engineering, doing oil and gas solutions. I've been working with partners doing the fracking operations, upstream, midstream, downstream solutions. So we have experienced team. And the key thing here is that we have competitive rates. We don't force you to hire a team of like 5 people for a tremendously huge amount of money. We have outsourced resources that are helping you guys to sort out your things. So if you're interested, please reach out. So to finalize, I would like to say that by integrating these strategies, by integrating the digital twins and other things that I mentioned before, you will be able to maintain accuracy and reliability, and you can make your work much more efficient. So one thing that I need to say is that the digital twins are hover over the machine learning models. It's offering the real-time adaptive insights instead of just historical pattern recognitions and predictions. With the right combination of deep learning, physics-based modeling, and cloud platforms, business can optimize operations and reduce risk and improve decision-making. So this is the main thing that drives your ROI high. So we need to think about the future. We need to think about investing into the new technologies. If you have any questions, please reach out to our team, hello@mltune.io. Would be great to help you out. Thank you very much.